syllabus. Alright, it was named as CRE. Alright, during my time, namanya CRE, Chemical Reaction Engineering. Okay, tapi nowadays kita dah tukar pada Reaction Engineering 1. Okay, so there are two major part, alright, in the Chemical Reaction Engineering, which is the chemical kinetic study. Okay, it's about the chemical reaction rate. Alright, how the the reactant. Okay, for example, A plus B. Oh, sorry. Such as for A plus B is equal to C. Okay, so how the reactant here react with another reactants to form a product, which is the C. Okay, so there must be a rate we have to calculate, alright, which is the K here. Okay, in order to know how fast is the speed of the reaction. Okay, so for the reaction mechanism, this one you will not learn it here. Okay, this one is in reaction number 2. Okay, for the next semester, insyaAllah. Okay, you also will learn about reactor design. Okay, for example, you need to know what is the operating conditions like temperature. Okay, alright, about the volume. Okay, for the various type of reactor. Okay, for example, we have a batch reactor. Okay, we have a CSTR, continuous state tank reactor. And then, sorry, we have a PFR. Okay, so this one you will going to learn lah. Okay, so basically this kind of reactor it has two kind of mode of operation we call. Okay, macam mana dia beroperasi. Okay, whether it is a batch ataupun continuous. Okay, this one I will explain later on. Okay, so this is the diagram, okay, of a reactor. We can see there is a pump here, okay, and then this is reactor. Okay, so the reactor has a range of sizes, all right. So you can see the pilot scale in the pilot plant, all right. In dia dekat dengan guard house, okay. Sepatutnya bila you learn CHE506 punya lab reaction, you will be introduced to hands-on the reactors lah, alright. Okay, so this is sekejap ya, I kena movekan benda ni sekejap. Okay, so this is the details of the diagram. Okay, you can see there is a stirrer here. Okay, then there is the product outlet here. Alright, then this is the reactant here. So it is controlled by the valve here. Okay, and then this is flow level. Okay, usually the level of the reactant here ataupun liquid here, okay, we call it as a working volume. Working volume. Okay, so usually the working volume will not occupy the whole reactor. Alright, there must be a head space here. Okay, but to avoid any build up pressure if anything happens here. Okay, for example, if the controller ke apa ke malfunction of the controller, alright, and then the liquid here will be increased here, alright, and it will can cause a rupture here. Okay, so to avoid any build up pressure, there must be a head space here. Alright, so in our syllabus, okay, reaction 1, okay, we assume that the volume of reactor is equaling with the working volume. Okay, so when we talk about the volume of the reactor, means that the volume working volume inside the reactor. Okay, so in order to know whether it is a batch of the or continuous mode of reactions, it depends on how you control the control valve. Okay, let's say it is a batch reactor. Means that, okay, before the reaction occurs, okay, you will allow the reactant to go inside the reactor, alright, and this product outlet, you need to close it. Okay, so you will feed it in a specific duration time, alright, and then you will close it back, alright, to let the reaction occur inside the reactor. Okay, so after this, sometimes when the reaction is completed, alright, then you release the product the WAF here, all right, for the effluent of the product. Okay, so for the continuous means that you need to what do you call it, open the WAF here, okay, let the reactant to be fed continuously. Okay. Alright, so a process in which at least one new substance is produced as a result of a chemical change. Okay, so how the chemical is being changed? Okay, this we learn after that. Okay, after this. Alright. Okay, at least one new substance means that at least there is A is equals to B. Okay, let's say macam tu lah. Alright, it could be more than one reactant also. And then the change of a substance into a new substance which has new different chemical identity. Okay, so from one reactant it will become a new identity here. Okay, all right, so for example we have an alkane here to produce alkene plus with the hydrogen, for example lah. And then we have a chemical reaction causes a chemical species to lose its identity. Okay, so a component species can lose its chemical identity. How? So this through this kind of mechanism. Okay, first we have a decomposition, which is molecule is broken down into smaller molecules, atoms, fragment. Okay, so if you can see, this is CH3. Okay, and then it will convert it into two molecules. All right, different molecules. We have a hydrogen here, and we have a molecule with a double bond here. Okay, but between the left and the right side, it will give the same number of the, like hydrogen, we have a H2 plus here, it will become 6. Okay, this one also 6. Okay, and then C is remain 2 and same like this 2. Okay, if it's not balanced, you need to add stoichiometric coefficient here. Okay, sorry kalau pagi saya macam hilang suara. Okay, for combinations, okay, which is you can imagine lah the word combine. Okay, there must be a two molecules macam attached together lah. Okay, so molecule atom to combine with other molecule or atom. Okay, for example, we have a benzene react with the propylene to form a cumene. Okay, for example lah. Okay, so another one is nitrogen with the oxygen. We have a nitric oxide gas here. Okay, so that you need to balance it, you need to put it 2 number as a coefficient here. So by the coefficient. Then we have isomerization. Alright, isomerization is molecule change in configuration. Okay, this one I think you learn a lot in the organic chemistry. Kita ada ortho, we have a para. Okay, macam mana dia change this molecule into sini different one. Dekat sini, instead of here, dia pergi ke sini. Okay. Alright, so reaction occurred how? Alright, it's a color change, formation of solid precipitate within a clear solution, evidence of a gas, evolution or absorption of heat. Okay, for example, kita boleh what do you call it? Kita boleh kita boleh macam kita boleh relate kan, okay, contohnya dekat equipment dekat rumah kita, okay, which is the kita boleh jadikan for example like oven. Okay, oven ni as a batch reactor. Okay, whereby you nak bake a cake. Okay, of course you have a ingredients, okay, which is the reactant. Okay, for example we have a flour, okay, we have a sugar. Alright, we have ataupun you nak and chocolate chips or so on. Alright, so this one will become, okay, after you put it in oven, alright, in certain duration, and you set into a specific what do you call it, temperature, you increase the temperature, it will become a cake. Alright, so if you can see, it will there is a change in color. Alright, from the ingredients, from the before the what do you call it, before it has been baked. Alright, the color would be different. Alright, and then formation of a solid precipitate within a clear solution. Okay, this one is more on you cannot compare dengan ni lah. Okay, different ni. And then we have an evidence of gas. Okay, so sometimes from the reaction, okay, it will what do you call it, it will produce a gas. Alright, for example like H2O ke CO2 ke. Okay, and then evolution or absorption of heat. Okay, that's why we have a term of endothermic and also exothermic. Okay, whether the reaction occur need a heat or it can release a heat. Okay, this one I will explain later on. Okay, so this is the how the what they call it the formula, equation formula looks like. Okay, for the combination A plus B, for the decomposition it will pecahkan, alright, separate, alright, into different molecules. We have AB into A plus B, and then we have a displacement. Okay, you can see for the reactant it is AB. Okay, when it becomes a product, it they change the punya ni lah side. Okay, it become AC plus with B. And then we have a metathesis reaction, which is double replacement reaction. Okay, from here, it is a single placement, right? For this one, it's a double. Okay, you can see AB akan bertukar pada AD. Alright, and then BC, AB akan jadi BC, right? And then we have a combustion reaction. Okay, for combustion, selalunya kita akan ada, what do you call it, ada fuel ataupun carbon base what do you call it, molecule. Okay, for example, kita ada ethane, alright, kita ada methane. Okay, so they react with the oxygen, dia akan berlakunya combustion. Okay, ini yang akan. Okay, so for industrial chemical process, the typical situation of chemical process is shown below. Okay, so first there is a raw material. Okay, so ada physical treatment. Okay, for example, raw material you ambil daripada oil palm frond lah katakan. Okay, pelepah fronds tu. Okay, so pelepah oil palm frond, so of course you need to undergo a physical treatment. Okay, for example, you kena kecilkan, so dia akan go through a process, cutting process. Okay, and then after cut, of course kita nak sievekan dia, alright, nak buang all the solid residues yang kecil-kecil tu, alright, to maintain a standardized, a standard, what they call it, the standard length of the oil palm fronds. Okay, so after that, need to be treated with a chemical. Okay, for example, sebab apa kita nak dapatkan smaller raw material yang kita dah proses tu, sebab bila a small material kita ada large surface area. So bila ada large surface area, kita apply a chemicals on it. Okay, contohnya kita nak convert something, alright. So you need to get in touch between the raw material dengan chemicals. Of course kena ada large surface area lah untuk lagi high efficiency of the treatment. Okay, so for example, inilah chemical treatment ni berlaku dalam reactor. Okay, the process. Alright, nak blendkan dia sekali lah. Okay, and then after that we have a physical treatment like downstream processing we call it. Okay, for example, for separation process. Okay, in order to get a high purity product. Okay, this is a reaction rate. Okay, you need to know. Okay, so reaction rate actually is Ri here. Okay, is equal to 1 over d and I over dt. Okay, so I here is referring to any kind of species. Any kind of species. Okay, you can denote it like A, B, C, D, and so on. Okay. Alright, this is we call as algebraic equation. Okay, so this one is based on unit of reactant fluid. Okay, if you can see Ri, alright, the reaction rate is equal to 1 over d. Okay, so this volume is the fixed volume. Alright, fixed volume. Okay, it does not change with time. Okay, so kalau it change with time, kita akan nampak over dt. Okay, means that when the volume change, the volume will change with respect to time. Alright, so at different time, contohnya kat T1, T2, the volume will be different. Okay, so volume ni adalah volume pada working volume tau, bukan volume of reactor kita tengok lah. Okay, yang as I explain to you lah, kita assume that volume of reactor is equal to volume of working volume, okay, of the liquid. Okay, so 1 over D is over D and I over dt. So N actually is the number of moles. Alright, so if we have a number of moles divided with V, actually we will have C, which is the concentration. Okay, so usually I akan letak simbol concentration macam ni lah. Okay, concentration of A, concentration of B. Okay, alright, so kita akan dapat kadang-kadang Ri is equal to dCi over dt. Okay, alright, then we have a base on unit mass of solid in liquid or a fluid solid system. Okay, so if you can see W actually is mass of solid. Okay, kenapa kita tak tengok pada fluid? Alright, sebab usually kalau ada fluid and solid system, alright, so the fluid ni being introduced in excess. Okay, so kita tak kira dia. Okay, so yang kita nak, what do you call it, consider actually is the berapa banyak mass of solid is being introduced into the reactor. Okay, that's why we have 1 over W is equal to, Ri, okay, we have prime here, single prime is equal to 1 over W dNi over dt, which is small I form over mass of solid times time. Okay, and then we have a based on unit interfacial surface in two fluid system, or based on unit surface of solid in gas solid system. Okay, so usually ni apply to inilah different kind of reactor. Okay, this one usually you akan learn in reaction number 2. Okay, so which is R double prime is equal to 1 over S. Alright, it's a bit, it is being what do you call it, calculate based on the surface area. Surface area. Okay, alright, dNi over dt, which is small I form over with the surface time. Okay, so this one okay, yang macam ni kita akan double prime ni actually adalah example of the falling, alright, film reactor. Okay, so usually kalau ada, okay, contohnya I bagilah gas and liquid. Okay, selalu gas masuk akan bentuk bubbles kan. Okay, so dia akan contact with the liquid here. Okay, so bila the gas touch with the liquid here, okay, there is a film being formed. Okay, so film ni lah kita akan tengok pada surface area dia. Okay. Okay, so this one you akan learn pada reaction number 2 lah mostly. Okay, and then we have a R triple prime, which is based on the unit volume of solid in gas solid system, which is 1 over Vs dNi over dt, and so on. Okay, so jangan risau, kita akan concentrate on this one. Okay, reaction number 1. Okay, so what is a reaction rate? Defined as the speed of reaction. Okay, so speed of reaction, kalau you tengok, adalah berkaitan relate with the time. Okay, berapa laju dia bergerak, okay, berapa laju dia punya proses, and so on. And then some reactions can be very, very slow. Okay, for example, sewage treatment plants. And we have also the very fast one, which is like a rocket engine. Okay, so the rate of reaction can be expressed as the rate of disappearance of reactant or the rate of appearance of a product. Okay, which is disappearance of A. Okay, which is A, dia akan convert into B. So dia akan disappear. Okay, another one, alright, it will be ataupun dia akan daripada B ni akan appear actually is from the A. Okay, so rate of disappearance usually dia akan dalam negatif, alright, sebab dia makin berkurang. And rate of appearance usually in term of positive, alright, sebab dia bertambah lah, dia become another product, into a product. Okay, so this is how fast lah the reaction rate. Okay, example, you can see the rocket, alright, okay, 10 to the power of 4, and so on. Okay, so rate of reaction if given of negative Ra equals to moles of disappearing meter cube of thing. Okay, so this one is lebih kurang macam yang tadi lah kita belajar, is Ra, alright, which is dCA over dt. Okay, ataupun you akan dapat 1 over V dNi over dt. Okay, so this one is the thing lah. So what is reaction rate? Is a concentration of a time, which is a dCi over dt. right? Ataupun dCA over dt. Okay, that's why I told you before, you will learn software, alright. Sebabnya, okay, when we have this kind of equation, alright, kita nak dapatkan profile graph, which is, this is a CA, katakan CA, this one is T. Okay, tapi kita boleh direct ni daripada sini. Okay, so from the software actually, we can calculate for, okay, CA ni T1 ni apa, CA2 T2 dia apa. So daripada situ kita boleh dapat profile dia kat sini. Okay, ni T1, ni T2. Okay, so that's why you akan learn software. Okay, so once you have a what do you call it, equation here, alright, the rate of reaction here, you can transform into a profile here. Okay, concentration profile. And then what is rate law or rate of equation? Okay, so reaction rate is defined as changes in concentration over time. Okay, this we have D ni masih changes lah. Alright, differential equation we call it. Okay, the unit would be the mole per liter second. Okay, sama juga macam tadi lah, kita ada dni over dt 1 over v. Okay, see this is v is a volume which is in liter, alright, ataupun in meter cube, alright, n is a mole, number of mole, and T actually is the time. Okay, usually we'll measure in a second. Okay, reaction rate can be quantified in terms of disappearing reactant or appearing products. Okay, okay, this is what we call as relative rate of reactions. Okay, which is we can equal it here. Okay, for each of the components involved here. Okay, for example, okay, A and B actually in the left side, okay, we call it as a disappearing ring. Disappearing. Okay, that's why if you can see, it have a negative here. Okay, so RA, okay, will divide it. Okay, we over with the stoichiometric coefficient here, which is A. Alright, and then we have it's equal to negative RB. Alright, so we over with the B here. Okay, and then we have RC. Okay, RC is the formation or the appearance one, so it should be in a positive. Alright, so RC over with the C and RD over with the D. Okay, so for example, why we need to do this relative rate of reactions? Okay, sometimes we want to calculate the RA. Okay, but the value given in the questions, maybe it gives the rate of reactions of D. Okay, so you have the RD value here, for example, X. Okay, so automatically you can also know what is the rate of reaction of the RC, what is the reaction of the RB, what is the reaction of the RA. Okay, for example, we have RA is equal to A. Okay, kita nak tahu what of the reaction of the A. Okay, given that the RD value is 2 mole per liter second. Okay, so katakan A ni adalah given here is 2 and D here is 3. Okay, so RA is equal over with the 2 is equal to RD, which is a 2 mole given in the questions. Okay, 2 mole over with the liter per second over with the D is 3 here. So automatically times here bahagi dengan ni, alright. Okay, 2 kali 2 4, 4 also 4 over 3 mole per liter per second, which is the RA value here. Okay, so you boleh dapat RA. So RB pun you boleh buat macam tu, replace je sini RB and so on. Okay, so consider this reaction. Okay, for A plus 2B is equal to C plus D. Okay, 4 moles of A, okay, reacted with the B, with the 8 moles. Okay, that's why dia ada 1, this one 2. So 1 kali 4, 4, 2 times 4 is 8. Okay, to produce C, which is 4 moles, and also the D 4 moles. Okay, so from here we know which is negative RA is a 4 moles A over D meter cube per second. Okay, so this is a reaction rate value. Okay, and then we have a B here, which is 8 moles. Okay, and then we have which is to produce 4 moles. Okay, ni, alright, and we have a D here. Mana D? Oh, D dia tak tulis sini. Okay, tak apa. So we have RA, RB, and RC. Okay, so A should be in negative. Okay, sebab dia dekat right hand side. Okay, dia akan disappear, dia akan degrade. Okay, so we have a negative RA, negative RB, same like B here. But RC, it should be in a positive. Okay, sebab they're being produced. Okay, so from here we have you can also put the negative here into the right side here. Okay, so it become negative 4. So bila kita tahu red reaction kalau ada negative means that dia adalah disappearance. Okay. Okay, so far okay ke semua orang? Okay. Okay. Alright, so katakan 2A plus B is equal to C. Okay, okay, what is for RA? Mari sama-sama kita jawab. Okay, kalau untuk RA apa dia? Anyone wants to answer? Okay, RA should be negative or positive right now?
Negative.
Negative. It should be negative RA. Okay, and then divided by what?
2.
By 2. Okay. And then we have another one which is the B. Alright, B should be negative or positive?
Negative.
Yes, should be negative RB is equal to divide over with
1.
1. Yes, and equals to, and C, is it positive or negative?
Positive.
It should be positive and then divide over with
2.
2. Okay, alright. Okay. So this is how you write down the reaction rate. Okay, so you will have the 1 mark here. Okay, so here what is the reaction rate of A and B if the rate of formation of C is 4 mole over decimeter cube per S. Okay, so they dah give this the value of the RC. Okay, so you just replace this one, the RC, which is 4. Okay, then you will be able to get what is RB, what is the RE here. Okay, so understand everyone?
Yes, madam.
Okay, good.
Yes.
Alhamdulillah. Okay. Okay, so 2.2 is about reaction rate for the rate of equation. Okay, so the rate of equation or the rate law is an algebraic equation that depends on reacting materials and reaction conditions. It is independent of the type of reactor, batch or continuous. Okay, so this one actually can be applicable to the type of the reactors. Okay, cuma you akan learn the different in term of the stoichiometry nanti. Dia ada F, dia akan ada ataupun ada N. Okay, nanti you akan learn in the third chapter, third topic. Okay, so let's say we have a to product. Okay, so benda ni adalah depending on the reactor materials. Okay, berapa banyak reactant ada. Kita ada kalau ada 3 A, B and C, and then dia akan bergantung pada reaction condition, which is the berapa banyak concentration dia as well as the temperature. Okay, so bila ada temperature nanti dia ada you akan relate dengan Rns equation. Okay, okay, so let's say we have a to the product. Okay, okay, so A to the product dia boleh jadi juga reaction ni. Okay, macam mana? Ini kalau ada 2A here. Okay, so 2A here dia akan jadi KC kuasa 2 A. Okay, so then we have a negative RA K1CA over 1K2CA. Ini kalau dia ada lagi panjang lah. Okay, which is maybe A to the P, and then we have another one what do you call it, A plus maybe with something equals to P. Okay, so that's why dia akan jadi macam ni. Okay, ni akan terang later on. Okay, so actually dia depends pada kita punya reactor punya types. Okay, so katakan ni adalah 3. This is product, so means negative RA is equal to KCA3. Okay, dia akan depends pada dia punya ni lah, stoichiometric coefficient. Okay, so K is rate constant which is temperature dependent. Okay, ni let's say kalau dia bergantung pada temperature dependent. Okay, for example we have a K1, dia berlaku dekat temperature berbeza. Katakan this one is 200 degree Celsius, lepas tu kita ada K2 300 degree Celsius. Okay, so setiap K ni dia akan rate of constant adalah bergantung pada different temperature. Alright, so negative RA is the function of the temperature and also the concentration. Okay, Okay, so we have a KCA. Alright, so ingat KCA ni lah is equals to negative RA. Okay, from here. Okay, equals to K naught E negative E over RT CA naught. Okay, so this one yang kita katakan this is the activation energy. Okay, they depend on the what do you call it, in the temperature. Okay, so alpha here is a reaction order. Okay, so ini I lupa nak cakap, this is N, which is the reaction order. Okay, kita ada reaction order of 1, 0. Okay, kalau 0 dia just KC sahaja. Sebab kalau C naught, C to the power of 0 is C sahaja. Okay, so this is a 0 order reaction. We have a 1, we have a 1 order of reaction, we have 2 order of reaction and so on. Okay, so nanti ni you akan I akan terangkan details lah dengan dia punya examples. Okay. So classification of reaction, we have a homogeneous and heterogeneous. Okay, selalunya homogeneous ni kita ada satu phase sahaja. Okay, for example in a liquid system only. Alright, so heterogeneous ni bila dia bercampur lah liquid plus S, okay, liquid dengan solid, so dia become heterogeneous. Okay, so this one kita tak akan belajar in reaction 1 lah. Kita akan mostly concentrate in homogeneous, alright, reaction. And we will learn about reversible and reversible. Okay, so irreversible adalah satu arrow saja, which is A towards B. Okay, tapi kalau reversible means B product pun dia boleh reverse back to the A. Alright, kalau you kacau dia punya dynamic reaction. Okay, for example A to B ni dia akan dihasilkan dengan energy dengan heat yang tinggi. Alright, temperature yang tinggi. So bila you kacau this temperature, you lower down the temperature, dia boleh convert back from the B towards the A. Alright, kalau you kacau dia punya condition. Okay. And then we have endothermic and exothermic. Alright, nanti akan explain lah apa beza endo dengan exothermic. Okay, and then this one tak apa, this one kita tak akan cover it here in reaction 1. Okay, this one you will learn about series and parallel reactions. Okay, sama ada contohnya kita akan belajar series or parallel of the reactor punya arrangement. Okay, for example kalau series kita akan ada this one with series. Okay, series. So selalunya kami akan tanya lah what is the X here and what is the conversion here. Okay, so you kena determine. Okay, and then we have a parallel. For example from here we have dia sambung pada PFR ke. Okay, so you akan learn this one in topic number 5. Okay. And then classification of reaction. Okay, we have a homogeneous reaction. Is a reaction that take place in one phase alone. Okay, macam I bagi tahu tadi lah, sama ada 2 gases, 2 liquid or 2 solid. Okay, for example, nitrogen oxide formation is between NO to plus O2 is equal to NO2. Or ethylene production is C2H6 equal to ethene plus the hydrogen. Alright, and then heterogeneous reaction is reaction that require the presence of at least 2 phases, okay, and occurs at the interface between the phases, alright, to proceed at certain reaction rate. For example, gas and solid, gas and liquid and solid. Okay. Okay, so obvious variable in homogeneous system are temperature, pressure, composition. Okay. So actually the working volume, alright, will be affected with these kind of factors. Okay, if you change the temperature, the working volume will be different. If you change the pressure, the working volume will be different. Okay. Okay, and then we have in heterogeneous, the problem become more complex. Materials may have to move from one phase to phase during reaction, hence the rate of mass transfer and heat transfer can become important. Okay, so bila dia berkaitan dengan antara dua kind of different phase. Okay, for example from liquid to solid. Okay, so bila dia berlaku transfer between jadi liquid ke solid, okay, of course then must be a mass transfer factor and also heat transfer. Okay, berapa banyak sebab dia ada being contact between 2 phases yang berbeza, so dia akan ada berlakunya mass transfer in between of the boundary here. Okay, so kita tak akan cover reaction 1, ni akan you belajar in reaction 2. Okay, So this is homogeneous. Okay, I tak payah details ni. Okay, so this one is a classification of fraction, whether it is irreversible ataupun reversible. Okay, for example, untuk A plus B is equal to C. Okay, this is one way of fraction. The C will not become A and B back. Alright. Okay, so contohnya you masak an egg. Alright. And then bila you masak, you akan dapat different kind of product. Okay. Okay, reversible, dia akan boleh bertukar balik. Okay, so for example, N plus 2 plus 3H2 is equal to ammonia. So ammonia ni pun boleh decompose balik into hydrogen and nitrogen. Okay. Okay, so bila dia reversible sebenarnya nanti bila you nak derive the key is kind of complicated sikit. Okay, this is we will learn later on. So what is exothermic and endothermic? Okay, so if exo means like acid, I akan ingat senang, dia ada perkataan acid. Okay, so dia akan release the heat. Okay, so in exothermic reaction, energy is released into the surrounding as heat. Okay, as a result of the temperature of the surrounding increases. Okay, so energy ni dalam ni dia akan bertambah, of course disebabkan energy ni kita katakan dia dalam bentuk heat. Okay, so bila you increase the temperature, of course you increase the energy in terms of the heat. Okay, so dia bertambah panas. Alright, so for endothermic pula is the opposite of the exothermic, whereby energy is absorbed. Okay, means that they become cooler than the surrounding. Okay, as a result the temperature of the surrounding drops. Okay, sebab dia dah absorb all the energy here. Alright, so the surrounding become less warmer lah. Okay, so when a reversible reaction occurs in a closed system, alright, example no reactants are added or taken away. Okay, ingat closed system ni adalah dekat batch lah. Batch mode of operation. Okay, so bila berlakunya proses tu, reaction, okay, kita tak akan supply reactant continuously. Okay, ataupun kita keluarkan dia at the same time. Okay, so kita tutup valve ni. Okay, so bila berlaku ni, alright, akan berlakunya equilibrium achieve. Okay, dia akan achieve pada equilibrium lah. Okay, in other word, the reaction goes at the same rate in the both direction. Okay, so we have a K1 here, alright, and then we have K negative 1. K negative 1. Okay, so benda ni akan sama, okay, is equal K negative 1 kalau dia dah reach equilibrium. Okay, bila dia reach equilibrium, alright, A n plus B is equal to C plus D, dia tak akan balik semula. C plus D is decompose pada A plus B, tak. Dia dah saturated kat sini. So for example, we have a exothermic reaction. Alright, so exothermic reaction ni ini adalah proses yang dia akan favorable kalau kita increase temperature. Okay, kalau kita increase the heat atau energy. Okay, so dia akan become favorable, means that the reactant akan produce so A plus B akan produce pada C and D. Okay, dia akan favorable. Tapi kalau you lower the temperature, alright, so dia punya heat absorb adalah less. So bila dia less being absorbed, dia akan decompose back to the A plus B. Okay, and vice versa. And then here pula endothermic, of course kalau endothermic dia akan favorable kalau direction dia decrease. Okay, so kalau kita increase the temperature, A plus B, dia akan more product. Okay, so kalau kita terbalikkan dia ni, kita decreasekan temperature dia, alright, dia akan become more kat sini. Okay, faham ya? Dia saya terbalikkan dia. Okay, so contohnya endothermic ni. Endothermic ni dia lagi favorable kalau you lower down the temperature. So bila you lower down, A dengan B ni akan tend to be converted more to C and D. Okay, tapi bila you decreasekan dia balik, okay, dia akan decreasekan balik dekat C and D ni, alright, dia akan back to A and B, dia akan produce more. Okay, alright, okay, faham ke semua? Faham ke? Actually, it's a logical explanation je lah benda ni.
Betul.
Faham.
Okay, faham. Alright, thank you. Kalau tak faham, cakap je, okay? I will repeat. Okay, and then we have a classification of reaction. Okay, ni tak payah sangat nak tengok. And then we have a classification of reaction single or multiple. Okay, so single reaction is A plus B is equal to C. Okay, multiple ni you akan belajar. Ingat tak dalam lesson plan kita ada multiple reaction. Okay, so multiple reaction, more than one kinetic expression to follow the changing composition of all reaction components to be represent progress for a single reaction. So we have a series dia akan bergerak terus lah. Okay, tapi kalau parallel from A, alright, kita kan akan ada ke S and we will have a here. Okay, sebenarnya benda ni ada dulu syllabus you kena belajar enzim dalam chemical reaction engineering, tapi dia dah keluarkan syllabus tu, dia masuk pada reaction 2. Okay, that's why kalau you akan belajar enzim, you akan belajar more pada kompetitif, non-kompetitif, banyaklah nak ada punya terms here. Okay, then we have a complicated scheme. Reaction proceed in a parallel with respect to B, tapi dia akan produce in a series with respect A, R and S. So we have a A plus B is equal to R, tapi lagi satu reaction we have a R plus B is equal to S. Usually kalau kita nak buat production, okay, kita nak produce something, okay, kita nak kawal ini sahaja. Okay, sebab the main objective is to get the R product. Kita tak nak R product ni jadi benda lain. Okay, unless you want this R to become a byproduct, yang valuable byproduct yang you boleh jual sekali. Okay, tapi kalau misalnya R ni is not you don't want any byproduct of R, you kena control in this equation only. You tak boleh jadikan R dia decompose benda lain. Okay, nanti you akan reduce the amount of the product being produced, being formed. Okay. And then classification of reaction, elementary of reaction. Okay, this is what we call as elementary. Okay, the rate of equation correspond to stoichiometric coefficient. Okay, so dia akan bergantung pada stoichiometric coefficient ni. Kalau you tengok, okay, H2 plus I2 is equal to HI. Okay, so this one is the negative R, H2 sebab dia negative. This is a reactant. Alright, is equals to K H2. Alright. The component for hydrogen plus with the I2 here. Alright, and then we have a consider a single reaction with stoichiometric equation which is A plus B is equal to R. Okay, and then we have the rate of disappearance. Okay, so the rate of disappearance, okay, katakan kita fokus pada A, rate of disappearance of A, so it should be K. Alright, here K. Okay, rate constant is equal to, we have A here, so we have a C. Okay, you kena letak dua. Okay, sebab dia dua reactant. So we have a CA here and have CB here. Okay, tapi kalau dia ada 2 here, so dia akan become 2. Okay. Okay, so such reaction is called a elementary reaction. Okay, dia adalah straightforward punya reaction. And then we have a elementary reaction are often represented by an equation showing both the molecular and the rate constant. Okay, so kita akan dapat juga daripada sini 2A is equal to 2R. Okay, so the rate of this appearance of A should be negative RA. Okay, is equals to the rate of the appearance of R. Okay, is equal to K1 CA2. Okay, so kena ada 2 lah sebab sini ada 2. Okay. Alright. Okay, then we have another one. Consider B plus 2D is equal to 3T. Alright, so kita boleh tengok pada rate of appearance, disappearance of B, rate of disappearance of D, and we have rate of appearance of T. Okay, so rate of equation that refer to B, reactant here, so should be negative RB is equals to KB, CB, CD. Okay, you kena tengok yang ni adalah reactant sahaja. Okay, dia tak akan masukkan dia punya produk dalam ni. Okay, sebab kita kalau nak measure, kita tak boleh measure rate of reaction untuk dua-dua, kita kena salah satu. So usually kita kena tengok berapa B being convert to T, berapa banyak D being convert to T. Okay, that's why rate of reaction is referred to reactant only. Okay, then we have a rate of reaction referred to D which is negative RD is equal to KD CB here. And then we have a CD. Okay, kita kena kuasakan juga dah sebab dia second order of reaction. Okay, and same goes to this RT. Okay, tapi RT kita kena ada positif sebab dia adalah appearance, the formation of product. Okay, so for non-elementary reaction is no direct correspondence between stoichiometric and rate. Okay, so benda ni adalah tak berkaitan dengan stoichiometry and rate satu sahaja. Okay, dia tak akan depend pada satu sahaja. Dia maybe ada series of reaction. Okay, that's why we have a K1, K2. Okay, maybe this A plus B equals to B plus C, and then this one maybe again B plus C equal to D plus E. So dia ada series of reaction. Okay, so you akan relatekan K1, K2, K3 ni berkaitan dengan reactant dia balik. Okay, so daripada sini dia become reactant, jadi dia akan jadi juga produk. So bila ni kita nak jadikan dia second reaction, of course kita ambil balik ni, masuk sini, maybe dia akan produce another one, maybe D plus C. So C ni bawa balik ke sini. So benda tu, that's why dia akan relate, kalau you perasan K1 dengan K2 kat situ. Okay, satu reaction B, katakan this one B. So RB dia akan relate juga daripada dekat sini K1 and this one is K2. Okay, that's why you akan nampak sama dengan ada dua kind of rate constant here. Okay, so this will involve a series of step of reaction. Okay, dia berbeza dengan elementary. Okay, for example ni juga. Okay, alright, tak apalah, ni mostly you akan learn in ni. Okay, so this one you need to be able to differentiate between the elementary and non-elementary. Tapi usually kita akan concentrate pada elementary lah dekat reaction 1. And then you kena tahu what is the rate of reaction. Okay, what is the rate law of reaction and what is the reversible reaction. Okay, this one I dah terangkan sebelum ni. Okay, so kita proceed to temperature dependency on Rns law. Jap, you nak break sekejap ke? Would you like to have a break?
Yeah.
Okay, kita break 5 minutes. Is it okay?
Okey doktor, boleh.
Sebelum kita sambung sikit je lagi, lepas tu kita buat exercise sama-sama sebelum I bagi tutorial. Alright?
Alright.
Okay, jumpa kemudian. Okay, everyone is ready?
Okay, Doktor. Ready, Doktor.
Okay, sebelum saya start, lupa nak cakap. Untuk yang next week kan kita ada public holiday on next Tuesday. We also will be having a public holiday for apa Deepawali kan on 4th November. So macam dia affect kita punya kelas time, kelas punya hari. Okay, Selasa and Khamis. So that's why for the next week I will provide you topic number 2 untuk recordednya. Okay, tapi the rest of the topic kita akan go for synchronous lah, like this morning. Okay, boleh everyone?
Boleh je, Doktor.
Okay, so saya akan provide yang topik nombor tu awal sikit lah, minggu ni jugalah, maybe after this class ke, so that you have time to do. And kalau you perasan, I gapkan tutorial dengan setiap topik baru. Okay, at least 1 week untuk you betul-betul faham lah and study well each of the topic before you do the tutorial. Okay, alright. Okay, let's resume. Okay. Ini sekejap ya, I kena share. Oh, I tak share, tak stop sharing ya. Okay, alright. Okay, okay, kita resume. This is last subtopic, okay, for this chapter. Is a temperature dependent term of a rate equations. Okay. Okay, so for many reactions and particularly elementary reactions, the rate expression can be written as a product of a temperature dependent terms and a composition dependent terms. Okay, so sama ada we have a Ri is equal to the function of the temperature. Okay, ini bukan kali tau, ni in the function, alright, ataupun in the function of composition. Alright, ataupun kita boleh what they call it, concentrate on the composition only. Okay, either one. This is practically well presented by Rns Law, alright, which is K is equal to K naught E, okay, to the power of E negative R over RT. Okay, so R is a constant. Okay, so this one we have a various of the value of the R. It's just that you need to choose the right one according to the unit. Okay. And K naught is a frequency or pre-exponential factor. Okay, E is the activation energy of the reaction. Okay, usually kita akan try nak dapatkan what is the E lah. And T is the temperature. Okay, and at the same concentration but at two different temperature. Alright, so disebabkan dia sama concentration, so kita boleh equatekan dia. Alright. Okay, contohnya kita ada K1CA, kita boleh equatekan K2CA. Okay, tapi dengan syarat dia ada same concentration. Okay, that's why you boleh letakkan dia ke bawah. Contohnya lah ni K1 ni, okay. So, alright, so we have a ln R2 over R1. Okay, is equal to ln K2 over K1 is equal to E over R1 over T1 minus 1 over T2. Okay, kenapa selalunya, sebab apa kita berubah, selalunya kalau you expand this equation, okay, to get rid the exponential, you kena ln-kan both of the side kan. Tapi disebabkan you get rid of the E, okay, that's why you have 1 over T1 minus 1 over T2. Okay, tapi kalau if you remain here ada negative, okay, alright, you kena terbalikkan dia, which is 1 over T2 over 1 over T1. Okay, tapi usually kita remove this negative lah sebab nak senang kira nanti. Okay, so remember 1 over T1 minus 1 over T2 ni biasalah ln K2 over K1. Okay, which is kita bawa ni ke bawah lah, which is this over K naught. Okay, okay, kalau kita ln-kan, alright, so E dengan ni dah ke sini kan, E over RT, alright, so we have a 1 over T, kita boleh dua terms here. Okay, sebab kita kalau kita buat what they call it, integration, of course kita kena ada between one point to another point, macam tu lah. Alright, so so K ni, kalau you tengok K ni akan berbeza, dia ada value sendiri untuk with respect T here. So K1 sini T1, K2 over T2. Okay, that's why kalau you nampak dekat Rns punya apa question, dia tak akan bagi contohnya ada CA ada dua A reactant. Okay, reactant A ni akan ada concentration lain, ni akan concentration, tak boleh. Okay, sebab this kind of equation they apply to same concentration also, only. Okay, alright. Okay, semua everyone clear or not? Okay. Ataupun kita pun boleh lagi satu term which is K, ataupun you boleh replacekan dia, K is equals to A E negative E A R T. Okay, ni nanti kita akan bincang lah in exercise. Okay, so let us look at the question here. Example, the temperature dependency of reaction K is determined by the activation energy and temperature level of the reaction. Okay, so milk is pasteurized if it is heated to 63 degrees Celsius for 30 minutes. Okay, so we have a 63 degrees Celsius for 30 minutes. Okay, but if it's heated to 74 degrees Celsius, it only needs 50 seconds. Okay, so find the activation energy of this sterilization process. Okay, so if you can see, there are two kind of K here, difference. Okay, alright, and then we have two different kind of temperature here. Okay, so automatically you can use this kind of equation here. Okay, the one that I explained to you lah just now here. Okay, sebab dia tak bagi pun different. Okay, so from here you just plug in lah. Okay, which is the ln R2 over R1 is equal to ln T1 over T2 is equal to E over R1 over T1 minus 1 over T2. Okay, sebab apa dia bertukar sini? Okay, sebab K selalunya kita akan reported dia dia akan inverse 1 over T. Okay, so K is usually in term of S negative 1. Okay, okay, so kalau you ni, you kena tukar lah, you boleh naikkan dia balik lah. That's why sebelum ni kalau you tengok, this one is K2 over K1 kan. Okay, so katakan 1 over dengan T1, 1 over T2 over dengan 1 over T1. So you naikkan lah. Okay, 1 over T2 times with the T1 over dengan 1. Okay, that's why you dapat T1 over T2. Okay, alright. So make sure bila you buat semua ni, you kena pastikan unit tu betul. Okay, sebab I takut nanti tiba ni you terus letak, you apply je ln T2 over T1 ataupun daripada situ you terus masukkan je, sebenarnya tak boleh. Okay, tengok balik dia punya definition dia. Okay, jangan tersilap. Okay, sebab K always in S negative 1. Okay, 1 over second lah. Alright.
Doktor, boleh ulang balik yang kenapa T1 over T2?
Oh, okay. Alright. Sebenarnya asal dia kan ln K2, ln K2 over K1 kan? Okay, kalau kita define rate constant ni, okay, rate constant, dia punya unit adalah S negative 1. Okay, which means dia adalah K is equal to 1 over time. Okay, so for this one, okay, kan K2 over K1 kan? Okay, so katakan K2, okay, saya letak sini K2, T2. And then we have a K1, 1 over T1. Okay, so kalau you nak buat equatekan dia, ln K2 over K1 is equals to ln, okay, okay, K2 adalah ni, 1 over T2 kan? Okay, and then over dengan K1 kan? 1 over T1, betul tak? Okay, that's why bila kita kan kalau ada per dengan ni, kalau ikut mathematical rule of thumb, sini naik kan? So kita ada 1 over T2 times with the T1 over 1. That's why dia jadi T1 over T2. Okay, faham?
Faham.
Okay, macam tu lah. So you kena ingat tau, K sebenarnya is not is equal to 10 second. K so unit dia lah, contoh K actually is equal to 1 over 10 second. Okay, so that's why ataupun 1 over, contohnya T2, T2 dia berikan adalah 15 second kan. So K2 adalah 1 over 15 second. Okay, faham?
Faham, doktor.
Okay, alright. Okay, alright. Okay, so jawapannya you akan dapat ni lah. So E yang you nak cari kan, which is the activation energy, E. Okay, so R is 8.314 J mol per K. Okay, so masukkan dia balik. Okay, then you get the 422,000 J over mol. That's the answer. Alright. Okay, tak ada suara ni. Pagi ni memang selalu tak ada suara. So activation energy and temperature dependency. Okay, ini rasa nak ke saya terangkan. Saya terangkan sikit lah sebab ini akan berkait dengan topik number 2. Okay, alright. So RE is equal to 1 over dNA over dt. Okay, kalau you nak measure something, you tak boleh directly ada differential equation. Okay, you kena get rid of it. Okay, remember bila you belajar calculus, okay, bila you ada differential equation, you nak dapatkan dia dalam bentuk macam ni sahaja, you kena integratekan dia. Okay, so integrate dia mesti sebelah kiri dengan kanan ada in term of changes. Okay, D ni saya selalu panggil changes lah, D ni yang ni. Okay, so dNA over ni, okay, so you keluarkan balik. Okay, so dNA sebelah sini, so akan naik sini V, akan naik sini dt. Okay, so that's why you akan dapat RAV dt, dNA is equal to RA V dt. Okay, so daripada sini kita akan integratekan dia. Of course, kita integratekan dia, kita kena ada one point. One into another point. Sebab apa? Kalau kita ada graph, okay, katakan this one is A, this one is time. Okay, kita ada graph yang ni. Okay, sebab apa you buat integration? Sebab you nak dapat setiap time yang berbeza. Okay, so daripada sini T0, T1 akan ada N1, NA1. Ni kiranya NA lah Saya mana tulis no. So sini N2. So sini akan ada N3 and so on. Okay, so dulu saya belajar kalkulus saya tak faham kenapa kita nak buat graph ni. Selalunya lah, dululah. Lepas tu bawa saya terfikir sebenarnya bila kita kira kecil-kecil ni, dia lagi accurate sebenarnya. Instead of you kira the whole macam, kan kalau you nak dapat, macam mana nak cakap, kita kan kalau ada curve, kita akan dapat straight line macam ni kan, maybe dia akan bentuk macam, yelah ada curve V, alright. That's why you kena buat satu-satu kecil-kecil macam ni. Okay, that's why bila you kira area under this curve, you akan lagi tepat lah. Ini contohnya lah, saya nak bagi tahu. Okay, so daripada sini kita akan ada point kan, kita integratekan dia. Okay, so this one of course kita kena start daripada NA0. Alright, bila NA0 ni sebab T0, T kosong, dia akan bersamaan dengan NA0. Alright, so bila you buat programming nanti, you nak kira ni pakai software, you kena ada ni tau. Kita panggil initial condition. Okay, so and then we have a NA dekat any time. Okay, so daripada sini you have a NA minus NA0. Alright, is equal to RA VT. Okay, so this one sebab kita nak in term of the RA, okay, that's why kita put dekat sini RA. Okay, so you just rearrange this equation to become this equation. Okay, so daripada N over V, sebab V dia volume tetap, so kita bahagikan terus dia dapatkan concentration. That's why kita have RA CA0 over minus CA 1 over T. Okay, so sebenarnya topik ni you akan learn for the next for topic number 2 lah. Kenapa you integrate ni? Sebab you nak dapat area dia nak kira. Okay, daripada situ kita boleh kira K dia and so on. Okay nak? Okay, so daripada sini kita boleh equatekan negative RA2 over R1. Okay, is equal to CA0, CA 1 over T2 dan CA over ni. Ini sebenarnya dapat daripada yang ni juga. Dia just nak cakap dia kenapa jadi macam tu. Ni. Okay, nak terangkan tu lah macam mana dapat. So daripada sini, basically dia akan sama. Okay, sebab dia punya concentration tak berubah. So that's why you boleh matikan dia. Dia become like this, T1 over T2. Ni yang terangkan lah tadi sebenarnya. Okay. So this is the, kalau same final concentration, dia akan dapat macam ni lah. Okay, dia just nak cakap lah benda ni adalah directly proportionate to this one. Okay, so dia dapat ni. So that's why macam mana you dapat this equation. Okay. Okay, juga so are you ready? Kita go very fast je ni. Okay, kita jawab ramai-ramai So what are the factors that control rate of chemical reaction? So apa benda yang mempengaruhi rate of reaction ni? Anyone wants to answer?
Temperature.
Jawab je. Jangan malu-malu.
Temperature.
Temperature, yes, temperature, okay. Temperature and composition juga, alright. Okay, so define the reaction rate. How do you define the reaction rate? Apa dia punya equation? Ingat dia algebraic equation. So, apakah dia punya jawapan? Okay, reaction rate ni sama ada dia akan jadi disappearance atau dia akan jadi appearance rate. Okay, so unit for reaction rate dia, unit apa? Ingat lagi, dCA/dt apa unit dia?
Mol per liter second.
Ya, betul. Mol per liter per second. Ya, yeah, correct. Okay, so this one, I lupa nak tulis. dCA/dt. Okay, so dia akan jadi mol per liter per second. Okay, so this one, the one that kita buat tadi, relative reaction rate. Okay, so we have ammonia here. React with the 5 oxygen become nitric oxide and also plus H2O. Okay, so kita ada 4 here. Okay, kita boleh buat, this is for A, this one for B, this one is C and D. Okay, so what is the rate at which oxygen is reacting? Okay, so you kena kira sebab dia dah give you during the reaction the ammonia is reacting at the rate of 0.24. Okay, so means that dia dah bagi nilai untuk R and H3. Okay, so nilai dia adalah is equals to 0.24 mol per liter, per second. Okay, ni ada per. Okay, okay. So for ammonia, what it would be? Is it negative or positive? For ammonia?
Negative.
Yes, negative. And then it should be over with what number?
4.
Okay, 4, correct. Alright, and then we have oxygen here. Okay, so what is the relative reaction rate? Should be minus or positive?
Negative.
Minus.
Negative. Okay, minus 0 to over with
5.
5.
Okay, so the question already given you the value of this one, right? So automatically you just replace, okay, which is 0.24. Okay, we over with the 4, negative RO2 over 5. Okay, so automatically you will have the negative RO2 is equals to the answer lah. Okay, darab je, so dapat ni. Okay, so again, what is the rate at which H2O is being formed? Kita tengok negative R and H3 over 4 is equal to, okay, for this one, is it positive or negative?
Positive.
Positive.
Yeah, it should be positive. So R, H2O, and then over with what number?
6.
Yeah, it should be 6, okay? Okay, so automatically the negative R and H3, okay, is equal to 0.24 over with the 4, okay, is equal to R, H2O over 6. So this one, dia akan automatically dapat RH2O, answer dia berapa, okay? So this one remain negative, this one is positive. Okay, this is how you answer the question. Okay? Ya Allah, saya tak buat numbering rupanya kat sini. Alright, okay. So so far faham semua orang? Are you okay?
Faham, Doktor?
Faham.
Okay, so for number 5 ni, the rate constant for the reaction between ClH2 at 230 degree and 240 degree have been found to be 0.163 and 0.348 L mol per second, okay, respective. Okay, so what are the values of EA in a kg mole and A for this reaction? Okay, so from here you can see it is given the value for the temperature, two kind of different temperature, which is this one is T1 and then this is T2. Okay, and then this one is L over mole per second. Okay, if you can see sebenarnya dCA over dt adalah mole per liter, mole liter per second. Okay, so sekarang ni dia dah terbalik dah. Alright, which is sepatutnya dia mole per liter kan, second kan, which is sebenarnya ini adalah dalam value 1 over RA. Okay, so daripada situ you kena buat directly lah ln R2 over dengan R1 is equals to ln K2 over K1, okay, is equals to E over R1R 1 over T1 minus 1 over T2. Okay, so daripada situ you kena cari what is the value of EA and what's value of A. So daripada sini you kena cari EA dulu sebab remember macam you nak dapat nak dapat A adalah is equal to K is equals to A times with the E negative RT. Okay, so you kena dapatkan ni dulu baru you boleh dapat masukkan A ni, nilai A. Okay, so daripada situ you try buat, I bagi jawapan dia adalah lebih kurang A dia adalah EA dia adalah 162.713 Jmol over mol. Alright, and then dia punya A, alright, I tulis je lah kat sini, A is equal to 1.286 times with the 10 to the power of 16. Okay, so saya nak tengok macam mana awak tengok pada ni, value ni. Okay, alright, sebab yang ni bukannya direct value of negative RA. Okay, sebab dia L mol per second. Okay, L per mol second. Okay, so try lah buat yang ni. Okay, and then for this one, okay, the activation energy for the reaction, alright, the tulis kat sini HI plus VI2 is equal to HI. Okay, so dia dah given the activation energy is 138. Okay, so dia dah bagi dah apa tu EA. Okay, so at 200 degrees Celsius, the rate constant has a value of 1.32 times 10 to the minus 2 L per mole per second. Okay, so dia dah bagi ini untuk T1. Okay, so this one kita tak tahu what is the T2. Okay, this one is K1. Okay, so basically kita tak tahu. So ini adalah kita kena cari what is the rate constant, means that what is the K2. Okay, so you should have the K2 is 6.0298 liter. Okay, that's the value. Okay, sekejap padam dulu lah semua ni. Okay, sana. Skype. Okay, masuk balik. Okay, alright. Okay, so from here pula, you calculate the activation energy for the decomposition of benzene, diazonium chloride to produce chlorobenzene and nitrogen based on data below. Okay, ini adalah different question tau. Okay, so kalau you nampak dia ada bagi banyak sangat K with respect to T. Okay, so K ni adalah pada T ni, K ni and so on. Okay, so bila you ada dapat this kind of data which is more than 2, okay, kalau daripada 2 data you boleh directly apply yang ln R2 over R1 is equal to ln K2 over K1 and so on. Okay, so daripada sini kalau dia ada banyak data, so K dia akan berbeza. Okay, EA dia akan you akan dapat cari daripada satu slope sahaja. So automatically you kena buat construct a graph which is ln K divided 1 over T. Okay, in order for you to get the slope. Alright, so the slope will represent the what they call it, the activation energy. Okay. So far clear ke tak? Nak saya terangkan ke kenapa dia ada slope ni? Alright, sebenarnya basically adalah daripada equation asal which is K is equal to K naught E to the power over RT. Okay, so daripada sini you akan dapat you pecahkan, you akan dapat ln K1 over K naught is equals to E over R 1 over T naught minus with 1 over T1. Okay, so daripada sini kita boleh tahulah this is, kita boleh pecahkan sebab dia with K with respect to T, so ln K, alright, is equals to, alright, you ingat kan kalau kita ada straight line, should be Y is equal to MX. Okay, Y is the Y axis, M is the kecerunan ataupun slope, alright, X is the X axis. Okay, so dari sini ln K E over dengan R dengan 1 over T. Okay, Alright, so kita boleh dapat this one should be represent the M. Okay, so M is equal to E over R. Okay, so kita boleh dapat daripada tu you kena construct a table, construct a graph here. Okay, in order for you to get the M here. Okay, okay, so the M would be is equals to terbalikkan, E is equals to M times with the R. Okay, so you can dapat the right slope. Kalau slope you lari sangat, you akan dapat jawapan berbeza lah untuk EA ni. Okay, so automatically you kena dapat EA dia dalam, alamak tak tulis lah pula. Tapi you try lah buat tu. Okay, are you okay or not? I terangkan konsep dia sahaja. Okay, so far faham ke tak?
Yang atas faham, yang bawah-bawah tak faham ada.
Yang mana? Start daripada mana?
Yang soalan tadi yang last sekali tu.
Ni last ni?
Oh.
Okay. Okay. Alright, soalan last ni you tak boleh apply directly guna benda ni. Okay, sebab benda ni adalah untuk kalau ada 2K dengan 2T. Okay, sekarang ni you ada banyak lebih daripada 2K dan lebih 2 daripada T. Okay, faham tak sekarang ni? Okay, so bila you tak boleh buat macam tu, you kena libatkan juga T yang lain. Alright, sebab EA ni sekarang ni adalah reflect pada K1, K2, K3, K4, K5. Okay, so macam mana you nak kira directly kalau guna ini sahaja? Sebab ini adalah untuk 2 je value. Tapi sekarang ni dia ada lebih. Okay, so bila dia lebih, yang you boleh buat adalah ingatkan saya cakap kalau kita kan ada K naught, E negative E, E negative E over RT. Okay, so benda ni sebenarnya you boleh jadikan dia dalam bentuk ln. Sebab you nak matikan ni akan ln kan. So bila daripada ln tu you boleh jadikan dia sebenarnya as a integration. So bila integration dia melibatkan area under the curve. Okay, so that's why you kena this one you expand kan, derive kan dia, you akan dapat ln K1 over K2 equals to 1 over R, okay, 1 over T1 minus 1 over T2 kan. Okay, so sekarang ni ini disebabkan kita lebih daripada 2, so kita boleh letak as ln K. Okay, sebab K yang berbeza akan dapat T yang berbeza kan. So equals to E over R, okay, 1 over T. Okay, so ln K1 ni dia akan T1 biasa, ln K2 dia akan T2 here sini. Okay, so daripada sini, alright, kalau you remember, kita boleh dapat a straight graph which is y is equal to mx kan. Okay, so y actually is referring to ln K. Alright, x ni adalah 1 over T value. Okay, so daripada sini m dia adalah E over R. Okay, faham tak so far?
Okay, faham?
Betul, faham? Okay, so daripada situ you
try
kena
buat dulu.
Macam mana? Tak dengar lah saya.
Tak, kena try buat dulu.
Kenapa?
Saya kena try buat dulu baru nampak.
Ya, okay. Saya macam nak bagi brief je, nanti you try buat lain sekali, okay? Alright. So, bila daripada sini, okay, remember kita ada y is equal to mx plus c, tapi sekarang ni kita tak ada c. Sini intercept. So, y is equal to mx saja. You kena adjustkan dengan equation ni. Sorry lah, ini memang suka conteng. Okay, so daripada sini kita tahu which is ln k is equals to m, kita dapat slope dia. X ni adalah 1 over t. Okay, so you akan plot sini ln k, sini adalah 1 over t. Okay, so you kena plot beberapa point lah. Equation sini ada berapa point? 1, 2, 3, 4, 5. So you kena ada 5 point here. So bila once you get a straight line here, okay, you will get the slope here, which is the m. Okay, so bila you tengok m ni sebenarnya adalah referring to E over R. Kan daripada sini. Okay, so m is equal to E over R. Sekarang ni kita nak dapat E sahaja. So E is equal to, you kena darabkan slope dia dengan R. So you dapat EA dia berapa. Okay, so far faham?
Faham, doktor.
Okay, selalunya kalau dia ada dalam jadual banyak-banyak macam ni, you memang kena buat graph. Okay, sebab you tak boleh directly guna ni. Ini adalah untuk 2 value sahaja. 2 K berbeza dengan 2 T berbeza. Okay, so after this you ada kelas ke?
Ada.
Ada.
Okey, kelas apa lepas ni?
Kelas
Project management.
Oh, alright. Siapa ajar?
Dr. Suhana.
Oh, saya off kan? Sebentar ada sorry, kita salah tekan button. Ya Allah, apalah. Okay, so itulah that's the end of our class today. Kita jumpa lagi lah next Thursday. Is it okay, everyone?
Okey, Doktor.
Okey, doktor.
Kita tekan salah buka.
Ingatkan Doktor tu left tadi.
Okey, doktor. Ingatkan terus left.
Bukan saya tak merajuk pun. Salah tekan sebenarnya. Okay lah, that's the end our class today. Kita end with tasbih kafarah and suratu as. Okay, thank you everyone. See you again.
Thank you, Doktor.
Thank you, doktor.
Thank you, doktor.
Thank you, doktor.
Gracias, doktor.
Thank you, doktor.
Thank you, doktor.